Now, the math menu will also calculate the median for us. Again, if we just have 8 data values, you could put those in order and pick the middle one, or even average the middle 2 faster than you could type all of that into Stat Editor. So I wouldn't use these functions if I only had 8 data values. But if I had 20 data values and I wanted to calculate several different measures of center, I'd rather just type them in a list and then let the calculator find each of these things for me. Now I'm ready to find the median. So go back to second and list. Move the cursor over to math again. And median is number 4. Either move the cursor down to 4 or just enter the number 4 and don't hit the enter button yet like I did. And then tell the calculator what list you want to find the median of, which is my list 1 again. Wow. The median of those 8 coaches' salaries is over 100,000 less than the mean. The median is only $325,074. Which do you think is a better representation of what NCAA coaches make? The $457,000 or the $325,000? Why do you say that? I would agree with you, but tell me why. Well, it's just 8 randomly chosen coaches. We don't know what they do. Yeah, we don't know anything about their responsibilities. Just 8 randomly chosen coaches, and their mean salary is about $458,000, but the median is only $325,000. Guess who that is? Bama fans. That's Nick Saban, the only man I'd leave my husband for. And he knows that. And Kate Hudson's the only woman he would leave me for. So I don't think either one of us is in danger of being left. Yeah, remember that resistant measure of center? If you have one outlier, one value that's drastically different than the others, that will drastically affect or can drastically affect the mean, but it's not going to affect the median. Let's go back and look at those original data values right here. Poor little coach making $150,000. The others are in the 200,000 and 300,000 range. Oh, well, there is one other person doing pretty well here, 810,000. But still, this coach is making almost 10 times as much as this coach and 4 times as much as that coach. So this coach is getting paid really, really well. Maybe it's because he's won 2 national championships in a row. I'm sorry if you don't like Alabama. I'm from Alabama. I'm not a traitor. I'm from Alabama, so it's okay. Let's see. What else do we need to do? We talked about that. Let's talk about mode. That's what's up next. The mode is the value that occurs with the greatest frequency. Sometimes a data set has just one mode. Sometimes it has no mode. Sometimes it has more than one mode. Bimodal means there are exactly 2 data values that occur with the greatest frequency. If you had $2 million salaries and all of the other salaries were different, 300,000, 400,000, 700,000, then that would be a bimodal set of data because that $1 million salary occurred twice, and twice was more than any of the other salaries occurred. So that's bimodal, 2 modes. Multimodal is just more than 2 data values occur with the same greatest frequency, and no mode is when none of the values are repeated more than once. Now, if there were 2 of everything, that would be multimodal. If there's 1 of everything, that would be no mode. Mode is the only measure of central tendency that can be used with nominal data. For example, if we listed all the makes of cars in the U.S. and then tallied up how many Fords there were, how many Chevrolets there were, we could find the mode of that data, but it doesn't make sense to average Ford and Chevrolet and Hyundai and Toyota. So you couldn't find the mean of those categories. You couldn't find the median of those categories, but you could still find the mode of those categories. Here are 3 different data sets. Data set A, let's see. All of the data values only occur once, except for the 1.1 occurs twice. So that's an example of a data set that only has 1 mode, and it's 1.1. Data set B, there are 3 27s, 3 55s, 2 88s, and 1 99. The 2 numbers with the highest frequency are 27 and 55, so that data set is bimodal. 27 and 55 are both modes. And then data set C, no value is repeated more than once, so that data set has no mode. All right, one more measure of center is the mid-range. That is the value midway between the maximum and minimum values of the original data set. If I had, go back to that set of data where 4 people made 85 and 1 made 10. I mean, I feel like that class did pretty well except for the 1 knucklehead. But if I just averaged the highest score, 85, and the lowest score, 10, then the class average, I would say the class mid-range is, what would it, about 47.5, I think, 47.5. That looks like the class did very poorly. So mid-range, you can use it if you have to. If you only know the highest score and the lowest score, you can use mid-range, but it's probably the least good measure of center because it is extremely susceptible to outliers. That 110 skewed the mid-range very, very much. Mid-range is extremely sensitive to extremes, but it is very easy to compute. My personal feeling on that is, yes, it's very easy, but it's worthless. So why even give it a name? The only time I would use mid-range is when the highest and lowest values are the only 2 that I'm given. Throughout the book, you will see round-off rules. The first time I taught this class, I was thinking every darn thing has a different round-off rule. You round off some to the nearest tenth, some to the nearest hundredth, some to the nearest thousandth, some to the nearest whole number, and I was afraid I was going to have to memorize all those round-off rules. You don't have to. On the homework and on the test, it'll tell you what to round to. The round-off rule for measures of center is carry 1 more decimal place than that is present in the original data set. So if everything in the original data set is rounded to the nearest tenth, you would give the mean to the nearest hundredth. 1 decimal place more precise than the original data, but again, it'll tell you that in the homework and on the test. All right. You didn't even really need me to talk about that. Yes, I spent, Lord have mercy. What time did we start? 8:30? 40 minutes talking about stuff that was pretty easy. There are two things that I was not going to have on the reading quiz, and I'm not going to go back and add them to the reading quiz, but two things that we do need to do examples of. One is the mean of a frequency distribution, and the other is a weighted mean. For example, remember frequency distribution? I have different classes. For letter grades, it may be 90 to 100, 80 to 89, 70 to 79. And then I just have the frequency of data values that occur in each class. Well, what if I want to find, I don't have the original data. All I have is the frequency distribution, and I want to find the mean of that frequency distribution. Well, here are those symbols again. You multiply each frequency times, well, each data value times its frequency. If there are 10 50s, then you multiply 10 times 50. You do that for each of the data values and add up all of those products. Then you divide by the sum of all the frequencies. Remember when we had a distribution, a frequency distribution, we could add up all the frequencies, and that's the total number of original values. That's all this is, divide by the total number of values. This formula makes sense when you think about it. If I had, say, 10 90s, 8 80s, and 7 70s, I wouldn't want to have to add all of those values individually. So I would just say 10 90s is 900, 7 80s is 560, and whatever else I said, and then divide by that total number rather than having to add all of the data values individually. One thing to notice here, it says use the class midpoint for the variable. So for example, I have a problem that we can actually work out. Calculate the mean from this frequency distribution. We have 5 classes. First class is 50 to 69, second class 70 to 89, and so on. I need to find the class midpoint, or the midpoint of each class, and use that as the, quote, average score, or whatever this is, in that class. So the class midpoint of the first class, 50 to 69, how do you find class midpoint? Yeah, just add them and divide by 2. 50 and 69 is 119, which is divided by 2 is 59.5. That's almost halfway between 50 and 70. Halfway between 50 and 70 would be 60, so that's reasonable. And I could keep doing that for the other 4 classes, or I could notice that my class width is what? 20, and just add 20 to get the next class midpoint. 79.5, 99.5, 119.5, and 129.5. Those are my class midpoints. What did I do? Oh, yep, thank you. 139.5 for that last class midpoint. Now that first class had a frequency of 24. I don't know, again, if these are scores, some type of scores. I don't know that I had 24 people who scored 59.5. I just know I have 24 people that scored between 50 and 59, or 69, and 59.5 is the best thing to use for I don't know how to finish that sentence. I started a sentence that didn't make sense. 59.5 is the class midpoint, so just use it and say, I had 24 people make 59.5. Somebody multiply those for me. Even? Yeah, it would be even. Okay. What about 79.5 times 228? $18.26? 18,126. Do I have a second on that? Okay. Third class, what's the midpoint times the frequency? Do I have a second? All right. Fourth class. Second? Okay. And last class. 3,627. Okay. I need to find out how many data values. Oh, these are IQ scores. Why didn't I look at the title to begin with? I don't know. IQ scores of 1,000 adults. If I had read the title, then I wouldn't have had to add these up, which is what I was fixing to do, to find the total number of data values, add the 24, 28, or 228, 490, 232, and 26. But they better add up to 1,000 since that's what the title said. What is the sum of these products? Has anyone added this up yet? Anybody second that? All right. All opposed, say nay. We've already talked about IQ scores being normally distributed. What is the normal, if you want to use that, IQ or average IQ of all adults? Well, technically, it's supposed to be right at 100. Is 99.66 what this one turns out to be? And that sample mean is very close to the actual population mean. This sample mean is 99,660 divided by 1,000, which is 99.6. Again, X bar stands for what? Mean of what? We have a sample mean and we have a population mean. Which one is X bar? Yeah, that's the sample mean. (99.6) just describes one measure of center of the sample. Now, and that's descriptive statistics. And starting in chapter 5, we will learn how to take the mean of a sample and use it to construct a confidence interval for the mean of a population. We might say, I want a 90% confidence interval. That means a range which I'm 90% confident the true population mean lies within.